Hello, hi, Assalamualaikum everyone. So welcome back to forward converter, which is also called isolated buck converter. So today we're gonna continue on, okay, from the previous class. So what we're gonna do today in today's class, we're gonna try to draw the waveform of the isolated forward converter. So the previous class, we have learned that the isolated forward converter is slightly different than the other converter that we have learned so far. We realized that this converter, okay, has the third winding, okay, which we call that as the N3. Okay, and this third winding is very important for us because the reason why the third winding is important is because at the high voltage, okay, when we have a transformer, okay, this transformer create the IMAC, okay, magnetizing current, okay, at a high voltage. So this I magnetizing current will be induced. So what will happen without the N3? Okay, the I magnetizing current has nowhere to be be fit. Okay, all right. There's no escape. So what happened if we have N3? So we can channel the I magnetizing back to the supply out. Okay, so if we don't have this path, what will happen? The circuit will explode, right? Okay, so today we're gonna learn about the waveform. All right, do you still remember about the three state the forward converter in? Okay, the first state, is okay. The first state is S is on, and then the second state is when the S is off, and then we have a third state when the S is still off, but this is during the core reset. Okay, so the forward converter has these three main state, switching state, yeah, because the S is the switch. Okay, so if we see, okay, where is the S? Okay, here is the S. Okay, this is the switch. Okay, so this switch has three. Okay, one when it's on, one is off, and also when it's off, but it's a core reset. Okay, all right. So that's what we're gonna have a look. Okay, so at this waveform, okay, because we have three main state, okay, so what will happen here, this is during when the S is on, okay, I will say this line, okay, till the end, okay, this is when the S is on, all right, and then at this point here, okay, at this point here, this is when the S is off. So all this dotted line here is referring to when the S start to off. Okay, so the point here when the D3 is off. Do you remember the time when the D3 is off is during the S, during this state, yeah? This is when D3 is off. Okay, all right. Okay, so D3 will follow this line as well. So at this line is where the D3 will start to turn off. This during the core reset. Okay, all right. So we're gonna draw our first waveform. Okay, so let's draw IL. Okay, so if you remember, IL is this current. Okay, so when the switch is on, okay, so means that the switch is connected. Okay, so what will happen here? Okay, so you will see that the D3 is off. Okay, all right, and but the current here will flow where ID1 is now equals to IL. So ID1 is also off. Okay, so let's have a look at that current. Okay, IL looks exactly like other IL from other previous converter. Yeah, okay. So at this stage, okay, so do you still remember the formula that we calculated DIL yesterday? Okay, so we're gonna write that formula because that's the gradient for this minus V out. Okay, and all of that divided by L. Okay, all of this. Okay, that's the gradient for, okay, let's change the color. Okay, let's change the color, the gradient to this color. Oops, sorry. Okay, all right, so that's the gradient. Okay, but when the S is start to turn off, okay, the supply, okay, doesn't supply anymore. Okay, all right, so when this is off, okay, all right, so this is open, so what will happen is there's no supply. Okay, so when there's no supply, you will see that, okay, the I current now reducing because now the ID2 is off and ID1 is on. Okay, all right, so if you don't remember, okay, just refer back to the previous lecture note. Okay, the previous video. Okay, right. So that's why the IL is decreasing. Okay, okay. Okay, so if you remember from yesterday, okay, IL still decreasing even though when this state, even though, okay, S is off and the core reset, we still have a decreasing IL. Okay, all right, so this part we just repeat because this part is again is the when the S is on. Okay, so this one just repeat again, so it's going up. Okay, all right, so let's see. Oh, we already have green, so let's take blue. Okay, so let's see ID2. Okay, do you still remember where is ID2? ID2 is this one, yeah? Okay, when the switch is on, of course the ID2 is on. And then when the switch is on, the ID2 equals to IL. Okay? Alright? So, means that when the switch is on, it follows, okay, IL. So, it follows the gradient of the IL. Okay, so, okay, right? But then, the IL. But then you realize when the S is off, okay, the ID2 is 0, right? Okay, so it continues on to be, sorry. Okay, continue on to be 0. Okay, when the D3 is off, it also continues to be 0. Okay, all right. Okay. Okay, so the whole of that is 0, yeah? Okay, right. So then if you see again, okay, so as okay, so if you see again when the S is on, of course it follows the gradient of IL. Okay, so it repeats again. All right, then of course, okay, it's the same. Okay, right. So at this part, we say ID2 equals to IL. Yeah. Okay. So let's see for other waveform. ID1. Where is ID1? Okay, so this is ID1. Okay, so when the switch is off, when the switch is on, okay, it's connected. So what will happen? Okay, ID1 is off. Okay, it's reverse bias. So when the S is off is when the ID1 start to turn on. Okay, so here, example, it will be 0. Okay, in the beginning. All right, but when the current start to when the switch starts to turn off, okay, what will happen to ID1? It will start to turn on. All right, so it will turn on, okay, this time all the way when the switch is off, okay, even during the D3 is off. Okay, all right, so that is for ID1, yeah. And then of course now, okay, it will start again when S is on. Okay, so that's for ID1. Okay, so here the ID1 equals to IL. Okay, right. So let's see other waveform. Okay, for example, I switch. IS is also called switching current. Okay, so IS is also called a switch current. Okay, so again, okay, if we label this part as the S on, okay, this is S off, the same, and this is S, sorry, not S, okay, but D3 instead. Okay, all right, so D3 is off, and this one it repeats again, it becomes S on, this become S off, and this become D3 off. Okay, all right, so now, okay, for IS, okay, what will happen? Okay, IS, when the switch is on, of course there's a current, yeah, Okay, all right. Of course, there's a is flowing. Okay, but of course, when the S is off, okay, when the S is off, what will you see? Of course, this is 0, yeah? Okay, of course, this is 0. Okay, and again, when the S is on, of course, there's a IS, repeats. And when the switch is off, of course, is 0 again. Okay, all right. Okay, so let's have a look at the IS. Do you still remember the formula? IS equals to N2 divided by N1 IL plus Imax. Okay, this is the formula that you have to memorize, okay? Because of this, IS has two components. One is IL and also Imax. Okay, so let's change the pen color. Okay, so now, okay, I use blue. So now you will see that if I draw dotted line, okay, this difference here and here, that is the iMac. Okay, all right. So if I change back, okay, the peak here, okay, this peak, sorry, this peak here, don't understand. Okay, all right, this peak here, it's called IS peak. Okay, is derived from this formula. Is this formula, yeah? All right, represent that. Okay, so means that, okay, this, okay, is actually, this is actually N2 divided by L. Sorry, IL. Okay, so it is part. Okay, all right. Okay, so that is for IS. Okay, let's have a look at ID3. Okay, let's use different color. Okay, so let's draw ID3. Okay, so ID3, when the current is off, when the current is on, of course, is off. Okay, so you start having ID3 when the S is off. Okay, so you see that which one is ID3? Let's go back to the circuit. Okay, this part is ID3. Okay, so when the switch is on, the ID3 is off, but when the switch is off, ID3 is on. Okay, ID3 is only on, okay, and what, at this state. Okay, but when it reached the core reset, the ID3 is off. Okay, so at the core reset here, ID3 is off, yeah. So it's off. Okay, and of course it repeats again. Okay, So when the S is on, of course it's 0 again. Alright, then when the S is off, of course we have a ID3. Okay, then of course is off during D3 off. Okay, alright, so that is for ID3. So let's have a look at other waveform, the voltage waveform this time. Okay, so let's have a look at V1. Okay, V1, because V1 is bifilar to V3, so we say that V1 and V3 is the same. Remember? Okay, because they are wound together. So in this part, okay, let's clear all this mess so that you can see better. Okay, alright. Okay, so if you see here, this is V1 and this is V3 because they are wound really close together. Okay, they are called bifilar. So that's why we say that V1 is equals to V3. Okay, it's not the same with N1 and N2, yeah? Because N1 and N2, we have an air gap here. So once we have an air gap, they are not bifilar. We cannot assume V1 equals to V2. No, we cannot. It never happened for transformer. So that's why we have the ratio, the transformer, remember? The ratio of the voltage, V1 and V2, because of the air gap. Okay, right. So here in this graph, we assume the V1 and V3 is the same due to, thanks to the bifilar properties. Okay, all right. So during the switch on, of course we have a V1 flowing, right? Okay, okay, so okay, just assume, sorry, okay, we have V1 flowing. Okay, then okay, so that is plus. Okay, when the switch is off, we still have V1, but this time is negative because we're no longer getting the supply. Okay, so what happened here? So we have a negative Vs. So that will be negative Vs. Okay, alright. But however, this negative Vs will go to 0 because during the D3, okay, what will happen? There will be no more supply of V1. Okay, alright, so this one will go to 0. Okay, and when the switch is on again, of course it will repeat again. Okay, so we have S1 again. Sorry. So this time, okay, the S1 is positive Vs. Okay, and when the switch is off, okay, we have the sorry. Okay, we have negative Vs. Okay, and then when the D3 is off, of course we don't have any more supply, so it's 0. Okay, so that is for V1, yeah. Okay, so let's have a look at the last waveform I want to show you today. Okay, so let's go for purple. So V2. So V2 is the same, okay, because V2 is also the ratio of Okay, so V2 is the same because remember V2 is the ratio. Okay, alright. So it follows the oops. It's very difficult for me to draw a straight line. Okay, alright, so it's the same. It will go to 0. Okay, again when the switch is on, of course we will have a V2. Okay, alright, and again when the switch is, oops, what happened to that? It's gone. Okay, alright. Okay, so of course now they repeat. Okay, alright, and then you have when the S is off, okay, you have a negative V2, and then when the D3 is off, of course there's no more V2, yeah, when the D3 is off. Okay, so for this one, okay, V2 is the ratio of N2 divided by N1 Vs. Okay, and then the negative is the same, N2 divided by N1 is Vs. Okay, alright. So basically that's for the waveforms. Okay, that's all that you have to learn. Okay, alright, I forgot to mention to you. Okay, here, if you realize, here is the peak for iMac. Okay, just to point out to you.